This is problem number 3 in section 4.2. The problem is find all eigenvalues and eigenfunctions for this eigenvalue problem, y double prime plus lambda y equals 0 on the interval 0 to infinity. The boundary conditions y at 0 equals 0 and y and y prime bounded as x goes to infinity. This is a singular Sturm-Liouville problem because the upper bound is infinite. To find the eigenvalues, we proceed in our usual fashion. We will guess y equals e to the rx, so that the characteristic equation is r squared plus lambda equals 0, which gives, as usual in this case, y equals plus or minus the square root of minus lambda. This is what we're working with. So we have, as usual, 3 cases to consider. Case 1, we'll take minus lambda equal to p squared, p positive. And this tells us that our general solution, we're going to use hyperbolic sines and cosines, a cosh p x plus b sinh px. Then y at 0 is, let's see, cosh at 0 is 1, sinh is 0, so this is a, so right off we get a equals 0. And so our solution, general solution, reduces to b sinh px. But we remember the graph of hyperbolic sine goes to plus infinity as x goes to infinity, so we need to choose b to be 0, and hence no eigenvalues in the range minus lambda equals p squared, not 0. Case 2, we'll take minus lambda equal to 0, which means we have a repeated root, and our solution then is y equals ax plus b. And we'll write down y prime is a. So the boundary condition y at 0 equals 0 tells us that b has to be 0. So b is 0. And now y equals ax, we notice is unbounded as x goes to infinity unless a equals 0. So lambda equals 0 is not an eigenvalue. Finally, the last case, case 3, the third possibility, is minus lambda equals minus p squared, p positive again. So this tells us that the general solution is y equals a cosine px plus b sine px. The first boundary condition, y at 0 equals, well, cosine is 1, sine is 0 is a, so a is 0. And here's our general solution. We'll notice that y equals b sine, this is px, sine px is bounded as x goes to infinity. And its derivative, y prime, is equal to bp cosine px is bounded as x goes to infinity. Therefore, every positive number lambda equals p squared is an eigenvalue, and with eigenfunctions y equals sine square root of lambda times x.